Pennsylvania, and I heard Virginia too. Pennsylvania, go ahead. We'll get right back with it. Okay, 209 Alabama, we'll tie it up. Obviously, you got a bunch of them calling. You just wanted to say it sounded good up here.
And yes, we are at a half channel.
Howdy over here in York, PA. Excellent there. That thing is superb. 169 Tennessee.
And you can see them bleeding in because they're only 5,000 hertz off.
Alright, 79, sounding good there. Yeah, maybe Hurricane Gordon's bringing us a few conditions in down here, so we're standing.
Okay, so what we got on isn't going to be a really long video. I'm already completely done with this. It's already put back together. It's a Galaxy DX98VHP. Customer sent this in to have an alignment done to it. Just take care of anything that I thought needed to be taken care of in it, and there really wasn't much. He did have 2 requests to have done to it. Now, first off, I can't remember, quite honestly, the last time I put my finger on a radio like this. So here we go. I'm touching it. A black box export radio that had no modifications. And it's used. It's not like it's brand new. It's been in the world. It's never had anything done. Limiters weren't clipped. It wasn't screwdrivered. It was just, I opened it up and I think almost had to pick my jaw up off the floor, because usually by the time I get them, they're just destroyed. But anyhow, so man, what a sigh of relief. No modifications, no screw turning. Honestly, the output power was down. I wouldn't call it severely, but it was actually, I think the AM carrier was at like 45, maybe 46 watts, somewhere around there. Where this, when you have the variable power turned up the whole way, it should be a 65 watt AM carrier and 200 watts on sideband. So, and it was out of alignment. It was really slanted power-wise, because this is a multi-band radio, has a band selector switch here. Band A had the highest power, and it just went down from there. But anyhow, the 2 requests the customer had was, would it be possible to be able to turn off the toaster oven on the bottom? He didn't say that, that's what I call them, the amplifier on the bottom of these. Absolute worst place. It's just completely physically impossible to put an amplifier in a worse place than on the underside of a radio. Where does all the heat go? Straight up into the radio. So yeah, between turning one of these things on and the temperature stabilizing inside, they probably drift a fair amount on this. You won't notice it on AM, but on sideband, you'd have to touch up with your clarifier a few times. Ideally it should either be on the back or on the top of the radio, not the bottom. Heat doesn't go down, heat goes up. But he wanted to be able to turn this off, and that's actually very simple to do in these. Just put a switch. Get away from here, fruit fly. These things are driving me nuts here the last couple days. Jarred peaches, and I think I left every fruit fly in the state of Pennsylvania in the blasted house. But anyhow, you just break the 8-volt transmit line that goes from the main radio circuit board to the amplifier board. That's what switches a transistor on in the amplifier module, and that transistor grounds the switching relay. So if you remove that 8 volts, the amplifier doesn't turn on, and then you just have basically a dual final radio. He also wanted to know if it would be possible to put some type of high cut circuit in this, so a noise filter, something to get rid of the static noise. Now, I'm pretty sure I did a video possibly on that. I'm close to 500 videos, I think, so I think I did one on that one time. But that's the main reason I'm doing this video, is I did it to this, and I want to demonstrate that. So yes, I did break, I don't want to say it's a cardinal rule. I don't like installing toggle switches in radios, drilling holes or punching holes, whatever, in radios. But in the case of this one, yeah, we now need 2 control switches. We need one for audio noise filter, or just basically a high cut filter or high frequency filter, and we needed one to turn the amplifier on and off. So they've been installed in the back here, the back left hand corner here. So they're out of sight, out of mind. Very neat, and like I say, they're in the back, so there's no holes drilled in the covers. I didn't drill holes in the faceplate, or all the controls on the front are still factory. And if anybody ever wants to remove those two modifications in the back, they can just pull those two toggle switches out and put hole plugs into those two holes. But yeah, I hate it when people put stuff in covers or faceplates, or even worse. But the filter. So the one thing he had on the note was, could I make it a stepped filter? So basically he wanted to know, I guess you could say, to have different levels of filtering. So in most radios that have a tone switch, and that's very common in radios, anything from Texas Rangers to some Cobras, Robins, you go back through the history of CB radios, and export, not so much export 10-meter radios, but especially CB radios. A lot of times you'll find ones that have either a variable tone control, or they'll have a on-off switch. So the on-off switch style is very simple. It's literally just a capacitor. That's all it is. You just need something somewhere around 0.1 microfarads usually is a good starting point. You can go down from that or up from that. And depending which direction you go, you'll have either less or more filtering, or you'll filter out more high frequencies. So I've got two capacitors in this one. The way I actually have them wired up is it's a 3-position switch. So in the center position, they don't do anything. And to hook it up in this radio, it's very simple. In most radios, you could do the same exact thing. They're just wired. Now, they're not wired on the volume control, but that's actually what they're attached to, where the volume, because this has a circuit board for all these controls. But the wiring harness for the volume control goes down to the main circuit board. At that plug, for the wiper, which is the output from the volume control, that then goes into the audio amplifier circuit. So that's where I wanted to intercept that, basically, that signal that's coming, it's demodulated audio that's coming out of the receiver, and then goes to the volume control, and then goes out to the audio amplifier. All I had to do was tack in. Now, if you wanted to add something permanently, you could just tack in a capacitor right there. From that point, from the wiper, and you can, wherever you can tap into the wiper circuit would be fine. But just tack one side of the capacitor to the wiper of the volume control, and the other side to ground. That's it. When the capacitor is attached to ground, that capacitor is now going to be filtering off those high frequencies and bleeding them off to ground, which most of your sizzling bake-in or the background or white noise, that's what it is. It's higher frequencies. Now, yes, it does reduce the audio bandwidth of the radio. Now, it's not in the receiver. The receiver has already done its job. It's received the signal, it's been down converted back into an audio signal, and it's then being fed into the audio amplifier circuit to come out of the speaker. So, but that's where we're a very easy place to intercept it, because it's no longer an RF frequency. We're now intercepting the demodulated receiver signal. So, like I say, just tack, and that's the easiest place usually to get to, is, like I say, it's low voltage here, so you don't need to go using, extremely high voltage caps, because honestly, if you could do it at the speaker, but you'd need to make sure your capacitors are appropriately sized. If you do it at the speaker, remember, you'd almost need to hook up a volume control. You'd need to hook up an oscilloscope to the speaker, turn the volume up the whole way, and feed an extremely large signal into the radio, something like, S9 or higher, modulated at 100%, turn the volume up the whole way, and take a peak-to-peak voltage measurement with your scope. Because that's the actual voltage that capacitor needs to be able to handle, would be that peak-to-peak voltage. So like I say, we're intercepting it at the volume control. It's a very small signal. It has not had any audio amplification yet. So any case, I stuck a 3-position switch in there. So when it's in the middle position, no capacitors are in circuit. When you flip it in one direction, that adds one capacitor, attaches. Now the capacitors are permanently attached. I have them attached. So on the circuit board, both of those capacitors that I have in here are attached, in essence, to the wiper of the volume control all the time. What the switch does is attaches the other side of those capacitors to ground. So the way I have it set up, when the switch is in one position, it applies ground to one of those capacitors, which applies some level of filtering, and then when you come back to the center position, there's no filtering, and then when you flip it in the down position, it adds a second capacitor in parallel. So I used a, what would that be? Double pole, double throw switch, yeah, DP/DT, that'd be, I guess, double pole, 6 terminal. So yeah, and then I had them jumpered across so that when I flip the switch in the down position, it adds both of those capacitors in circuit, which is a higher capacitance value, which is going to filter even more audio off, more of the higher frequencies. Actually, it'll be starting to encroach into the mid-range frequencies, actually. So let's give it a listen here. So we have the noise blanker A&L is just completely turned off. Turn the volume up some. So this is in the center off position. That's in the up position, which is bleeding off some of the high frequencies. And I'll flip back and forth between that one a couple times. And now I'll flip it into the downward position, which will add even more capacitance. So there's none, a little bit, and the most. And it works really well. So, and of course, see if we can get any skip coming in. That's actually the first skip I've heard in almost 2 weeks. I had to quick grab the camera and swing the arm around here because there hasn't been any skip here in literally 2 weeks. It's just been that, dead silence. Sounds like everybody's starting to fade out now. I don't know if there's anything on AM. Oh yeah. If sideband skips coming in, you know the loudmouths are coming in on 6. So there's no filter. That's in the up position. And that's in the low position, which is maximum filtering. Okay, that's about all my eardrums can take of that. There's no filter. Let's call that medium filter. And maximum filtering. God, they're just as bad as Channel 6, aren't they? And then, of course, we still have use of our A&L noise blanker switch here. So, let's see, that's with the capacitors disabled. That's with the A&L noise blanker on. And then with switch up. And then switch down. And I don't know how well it shows up in camera, but in practice playing around with those, what you'll usually find is Yes, you definitely are limiting your audio bandwidth. Like I say, you're not actually affecting the receiver's audio bandwidth. You're intercepting the audio, the demodulated audio, but you're shrinking, you're cutting off the high end. You're not affecting the lows at all. You're reducing the highest frequency, basically, that can come out of your speaker. The more capacitance you add, the lower that frequency is. But the advantage of that is most of your noise, this, like I say, sizzling bacon, white background noise, the crackle, the hiss, whatever you want to call it, most of that is usually in the higher audio frequencies. So I was actually playing around with this a little bit earlier when there was just a local, some truckers on channel 19. They were driving away from me, and as the two guys that were talking got far enough away where I was actually having a hard time starting to hear them, I played with that toggle switch, and when I had it in maximum filtering, I could understand them again. If I put it back into no filtering, noise blanker on or off, it didn't matter. I was really having a hard time understanding them. But when I flipped the filter to its maximum filtering, now don't get me wrong, it's still a very weak signal, but I could now understand them. Because I wasn't trying to listen to their voice over all that static. So they work really well, especially if you're doing DX, like on sideband especially.
New cell phone here recently. You got a new phone, Pennsylvania, gold through here with the van moving on. Superbug, I heard you come in there a minute ago. You rascal, where'd you go? The flash saw waving hand, Superbug.
So there's up, down, up, and center.
There's somebody around Pennsylvania.
Come on, talk again. But here's a good example. There's nobody on, so we'll flip the switch up, off, on, and then in the other direction, off, on. Like I say, it does a really good job at cleaning it up. So, and that's not for everybody. And the amount of filtering, like I say, you can play around with that. Personally, what I use, and quite honestly, it really doesn't matter what type of non-polarized capacitor. That's basically the only thing is you could use a ceramic, you could use mica, mylar, poly dip. Good Lord, you could use polycarbonate, polypropylene caps. It really doesn't matter. I usually just use the poly dip caps, like these, green ones, doesn't matter what color they are, but, poly dip caps, green, brown, they come in lots of colors. I've got, depending on value, I've got them in brown, blue, but, yeah, that's what I usually use. They're a little bit, honestly, probably a little bit better for audio. Now, granted, in a CB radio, you quite honestly probably would never notice a difference, but that style of capacitor for an audiophile, if you're dealing with like a guitar amplifier a lot of times, or with a high-end, high-fidelity stereo system, a lot of times you'll find that ceramic capacitors can be a little bit sharp in their response, where the poly-style caps are a little bit smoother and they don't have such a sharp edge. But yeah, it's a CB radio. Honestly, that's why I say in something like this, it really doesn't matter. These are about as low fidelity when it comes to the audio circuits in these things. Everything from basically the volume control to the speaker in any CB radio, it's low quality audio. The audio amplifiers, all the parts in it. It's not like they're using extremely low THD noise figure style, operational amplifiers in there, or even the audio amps. They get the job done. And they're cheap. That's why they use them.
I'm back leading this leader. Peacemaker standing down.
just going to blow in his microphone.
Superstar, everybody star. Transmit well done, no doubt about it. I want to thank you for your time on that topic again. I know it's been rough and tough on that topic again. Don't seem like we got Mother Nature.
Okay, that's all my brain cells and eardrums can handle of that. So, in any case, there you go. There's a Galaxy DX98VHP. Like I say, really didn't need much other than an alignment. I did resolder a bunch of solder joints on this thing. It does look like it was probably used in a mobile environment, especially if this power cord's any indication. It's just sun bleached. It's white on one side and red on the other. So yeah, this thing looks like it's been definitely exposed to some serious levels of ultraviolet light. But there you go. So yeah, like I say, there's not much to it. Sticking in a simple, either what you want to call it, a tone switch or a high cut. It's pretty much the same thing in most CB radios. Tone or high cut are the same function. It's usually just adding a capacitor, and what it does is it's basically taking the high frequencies and shorting them to ground. It's just taking them away. It's making them go away. And the advantage of that is that's where most of your noise is in the higher audio frequencies. Now, if you're an audiophile, don't bother, because you're not going to do anything but complain about, the audio's so narrow now. Well, yeah, but with the filter, you can hear stuff you couldn't when you had a wider audio spectrum. So there are advantages and disadvantages. Restricted audio bandwidth, but increased ability to be able to understand, especially DX signals.